Good day, students. My name is Harvey J.C. Tuling. I am your teacher for today's discussion. We will be discussing the introduction to chemical bonding. So before we start, do you have any idea, guys, about the chemical bonding? Okay, Mr. Rodriguez, you got it right. So to pursue, what is chemical bonding? Chemical bonding is one of the most basic fundamentals of chemistry that explains other concepts such as molecules, reactions. Without it, scientists wouldn't be able to explain why atoms are attracted to each other or how products are formed after a chemical reaction has taken place. To understand the concept of bonding, one must first know the basics behind atomic structure. So without chemical bonding, guys, hindi natin malalaman if ang certain product paano siya na gawa because of the reaction. So let's continue to the atom, students. A common atom contains a nucleus composed of protons, neutrons, and electrons. In this section, the main focus will be on these electrons. Elements are distinguishable from each other due to their electron cloud, or the area where electrons move around the nucleus of an atom. Because each element has a distinct electron cloud, this determines their chemical properties as well as the extent of their reactivity. The noble gases are inert, or not reactive, while alkaline metals are highly reactive. In chemical bonding, only valence electrons, or the electrons located in the orbitals of the utmost energy level, or what we call the valence shell of an element, are involved. So let's continue to the Lewis diagram. So students, this is just a review about the Lewis diagram since we had a Lewis diagram in our grade 9 and senior high school. Lewis diagram are graphical representations of elements and their valence electrons. Valence electrons are the electrons that form the utmost shell of an atom. In a Lewis diagram of an element, the symbol of the element is written in the center of the valence electron. So, nasa sa center. Tapos, and drawn siya as dots dun. The position of the valence electrons drawn is unimportant. However, the general convention is to start from 12 o'clock position and go clockwise direction to 3 o'clock, 6 o'clock, 9 o'clock, and back to the 12 o'clock positions respectively. Generally, the Roman numeral of the group corresponds with the number of valence electrons of element. Below is the periodic table representation of the number of valence electrons. The alkaline metals of group 1A have 1 valence electron. So yung red dyan is yan yung group 1A. The alkaline earth metals of group 2A have 2 valence electrons. So yung parang gray ba yan or violet na may 2 na numbers sa table of elements, yan yung group 2A. Group 3A has 3 valence electrons and so on. The non-indicated transition metals, lanthanoids and actinoids, are more difficult in terms of distinguishing the number of valence electrons because they have, however, this section only introduces bonding, hence they will not be covered in this unit. To draw the Lewis diagrams for molecular compounds or ions, follow these steps below. We will be using H2 as an example to follow. So H2 yung gagamitin natin to draw the Lewis diagram for molecular compounds and for ions. First step is to count the number of valence electrons of the molecular compound or ion. Remember, if there are 2 or more of the same element, then you have to double or multiply by however many atoms there are of the numbers of valence electrons. Follow the Roman numeral group number to see the corresponding number of valence electrons there are for that element. Example, for the oxygen, group 6A, therefore, meron siyang 6 valence electrons. Sa hydrogen, group 1A, therefore, meron lang siyang 1 valence electrons. Note, remember guys, there are 2 hydrogen atoms, so multiply 1 valent electron times 2 atoms. So in total, there are 6 plus 2, so 8 valence electrons. So the second step, if the molecule in question is an ion, remember to add or subtract the respective number of electrons to the total from step 1. For ions, if the ion has a negative charge or what we call the anion, add the corresponding number of electrons to the total number of electrons. Example, if NO3 has a negative charge of 1, then you add 1 extra electron to the total. So 5 plus 3 times 6 equals 23 plus 1. Therefore, ang total na electrons is 24. A sign means the molecule has an overall negative charge, so it must have this extra electron. This is because an ion have higher electron affinity or the tendency to gain electrons. Most anions are composed of nonmetals which have highly electronegativity. So let's proceed guys. If the ion has a positive charge or what we call the cation, so we need to subtract the corresponding number of electrons to the total number of electrons. So H3O has a positive charge of 1, so you need to subtract 1 extra electron to the total. It follows that 6 plus 1 times 3 equals 9. So yung total 9 minus 1 equals 8. So yung total ng electrons is 8. A plus sign means the molecule has an overall positive charge, so it must be missing 1 electron. Cations are positive and have weaker electron affinity compared to the anion. They are mostly composed of metals. Their atomic radii are larger than the nonmetals. This consequently means that shielding is increased and electrons have less tendency to be attracted to the shielded nucleus. From our example, water is a neutral molecule, therefore no electrons need to be added or subtracted from the total. For the third step, write out the symbols of the elements, making sure all atoms are accounted for. Example, H2O, write out O or the oxygen and 2 hydrogen on either side of the oxygen. Start by adding single bonds, 1 pair of electrons, to all possible atoms while making sure they follow the octet rule, with the exceptions of the do-it rule and the other elements mentioned above. The fourth step, if there are any leftover electrons, then add them to the central atom of the molecule. So the XeF4 has 4 extra electrons after being distributed. So the 4 extra electrons are given to the Xe likes. So finally, rearrange the electrons pairs into double or triple bonds if possible. So dito sa screen nyo, yan yung example kanina sa steps. So the hydrogen, oxygen, the H2O, and then the XeF4. So yan siya guys, yung pag-distribute nila. Let's proceed to the octet rule. Most elements follow the octet rule in chemical bonding, which means that an element should have contact to 8 valence electrons in a bond or exactly fill up its valence shell. Having 8 electrons total ensure that the atom is stable. This is reason why noble gases, a valent electron shell of 8 electrons, are chemically inert or inert rather. They are already stable and tend to not need to transfer of electrons when bonding with another atom in order to be stable. On the other hand, alkaline metals have valent electron shell of 1 electron. Since they want to complete the octet rule, they often simply lose 1 electron. This makes them quite reactive because they can easily donate this electron to the other elements. This explains the highly reactive properties of group 1A elements. Basically, what is octet rule? Some elements that are exceptions to the octet rule includes the aluminum, the Al, phosphorus or P, sulfur or S, and xenon as Xe. So hydrogen and helium follow the duet rule since their valence shell only allows 2 electrons. There are no exceptions to the duet rule. Hydrogen and helium will always hold a maximum of 2 electrons. So, duet rule yung hydrogen and helium since yung maximum ng electrons nila is 2 lang. What is ionic bonding? Ionic bonding is the process of not sharing electrons between 2 atoms. It occurs between a nonmetal and a metal. Ionic bonding is also known as the process in which electrons are transferred to one another because the 2 atoms have different levels of electron affinity. So, magkaiba sila ng electron affinity. In the picture below, a sodium Na ion and a chlorine Cl ion are being combined through ionic bonding. Na plus has less electronegativity due to a large atomic radius and essentially does not want the electron it has. This will easily allow the more electronegative chlorine atom to gain the electron to complete its third energy level. Throughout the process, the transfer of the electron releases energy to the atmosphere. So, ito yung ionic bonding na sinasabi kanina. Ito yung example na sodium at saka yung chlorine. So, another example of ionic bonding is the crystal lattice structure shown below. The ions are arranged in such a way that shows uniformity and stability, a physical characteristic in crystals and solids. Moreover, in a concept called the sea of electrons, it is seen that the molecular structure of metals is composed of stabilized positive ions or the cations and free-flowing electrons that weave in between the cations. This attributes to the metal property of conductivity. The following electrons allow the electric current to pass through them. In addition, this explains why strong electrolytes are good conductors. Ionic bonds are easily broken by water because the polarity of the water molecule shield the anions from attracting the cations. Therefore, the ionic compounds dissociate easily in water, and the metallic properties of the compound allow conductivity of the solution. So, dyan makikita nyo sa screen yung ionic bonding ng potassium tsaka yung boron. So, boron will gain the electron, the potassium will lose its electron. So, ionic bonding were formed after that. Then sa baba, the magnesium and chlorine ionic bonding. So, the magnesium will lose 2 electrons. Then yung each chlorine will gain an electron. So, ionic bond form after that. So let's proceed to the covalent bonding. Covalent bonding is the process of sharing electrons between 2 atoms. The bonds are typically between a nonmetal and nonmetal. Since their electronegativity are all within the high range, the electrons are attracted and pulled by both atoms' nuclei. In the case of 2 identical atoms that are bonded to each other, also known as nonpolar bond, explained later, they both emit the same force of pull on the electrons. Thus, there is equal attraction between the 2 atoms. So, example given is the oxygen gas or the O2 have an equal distribution of electron affinity. This makes covalent bonds harder to break. So, all these diagrams shows the formation of covalent bonds as electrons from elements are shared to form single or double and triple bonds. So, the hydrogen and oxygen covalent bonding, oxygen carbon and covalent bonding, and the nitrogen and nitrogen covalent bonding. There are 3 types of covalent bond: single, double, and triple bonds. A single bond is composed of 2 bonded electrons. Naturally, a double bond has 4 electrons, and a triple bond has 6 bonded electrons because a triple bond will have more strength in electron affinity than a single bond. The attraction to the positively charged of nucleus is increased, meaning that the distance from the nucleus to the electron is less. Simply put, the more bonds or the greater the bond strength, the shorter the bond length will be. In other words, bond length triple bond is less than to double bond, and double bond is less than to the single bond. So what is polar covalent bonding? Polar covalent bonding is the process of unequal sharing of electrons. It is considered the middle ground between ionic bonding and covalent bonding. It happens due to the differing electronegativity values of the two atoms. So electronegativity is different from each other. Because of this, the more electronegative atom will attract and have a stronger pulling force on the electrons. Thus, the electrons will spend more time around this atom. The symbols below indicate that on the fluorine side, it is slightly negative, and the hydrogen side is slightly positive. So guys, what is polar and non-polar molecule? Polarity is the competing forces between two atoms for the electrons. It is also known as the polar covalent bond. A molecule is polar when the electrons are attracted to a more electronegative atom due to its greater electron affinity. A nonpolar molecule is a bond between two identical atoms. They are the ideal example of covalent bond. Some examples are nitrogen gas or the N2, oxygen gas or the O2, and hydrogen gas as H2. Guys, makikita nyo sa screen yung table of elements. So, one way to figure out what type of bond a molecule has is by determining the difference of the electronegativity values of the molecules. So, if the difference is between 0.0 to 0.3, then the molecule has a nonpolar bond. So, remember guys, 0.0 to 0.3 is nonpolar. Then if 0.3 to 1.7, therefore, the molecule has a polar bond. 0.3 to 1.7. And then, if 1.7 or more, then the molecule has ionic bonding. So, ang difference nila is 1.7 or more, then the molecule has ionic bonding. So, huwag nyo kalimutan guys. That's all for today guys. I hope you understand something about the chemical bonding. Again, I'm your teacher, Harvey J.C. Tooling. Goodbye and thank you.